I've read a lot about different things in climate change ever since I came to the Senate. One was from a book by a geologist that says that we've been having climate change for 18,000 years, and that's only because the cores that they could find were 18,000 years old. So it must have been changing for ever since the dinosaurs, I guess. I've always thought the sun was the biggest driver of whatever happens in the world. And I did read in some place that there's a elliptical ride around the solar, the planets that revolve around the sun. And every so often they kind of line up a little bit closer to a line next to the sun, and that is supposedly causes different changes in the temperature that the Earth gets, because it pulls it into an ellipse instead of a perfect circle around the sun. Is there any scientific stuff behind that, or would you just say that it's not possible?
Absolutely. There's a terrific scientific background for that. These are called the Milankovitch cycles. And Milutin Milankovitch worked these out mathematically by studying the geometries of the planetary, of our entire solar system, the planetary orbits around the sun and their impacts on the gravitational pull with respect to the Earth and the Earth-Sun system. And there's actually three effects, and you quite correctly point out that our orbit around the sun goes from an ellipse to a more circular orbit. But in addition to that, we're like a top that's starting to precess. And so our pole, which currently points towards the North Pole, North Star today, it didn't 11,000 years ago. It was off axis with that North Pole because we're tilting. And that doesn't seem to, why would that affect anything? Well, whether we're pointed towards the sun when we're in an elliptical orbit, so we're now far away from the sun or we're close to the sun, and where our pole faces, that'll define how much energy we receive on a seasonal basis. And so these are very important processes. It comes back to the sun, it comes back to how much solar insolation we receive, but it distributes it, or we see a variability in its distribution with latitude. So at some times we'll have, we're close to the sun, what we call the perihelion, when we're pointed towards the sun. So we have our hot summers in the northern hemisphere and cold winters, and that'll switch after another 11,000 years till we have mild summers and mild winters, and these have a terrific impact, and we find very good correlations. In fact, these are the effects that really define the ice ages. So it's solar radiation, but it's the variability or the evolution of solar radiation with respect to latitude. And so these are well documented, and we see these cycles appearing in many, many terrestrial records. And it comes back to how much solar radiation we receive at different latitudes and at different times of the year. So you're absolutely correct. There's very strong science behind that.
Thank you. I'd forgotten to speak about the tipping of the polar things. They actually said that was what
well, that's
caused
you're quite right.
In the North Pole one time and colder in the South Pole, and it can reverse when it straightens out again.
There's actually those three cycles. So you just brought up the one that I overlooked, which is the inclination or obliquity. So our Earth's axis, rotational axis, actually, in addition to wobbling like a top, it goes over more and comes back up more. So we're more oblique. The pole is closer, more directly pointed towards the sun, or back. And this has it's actually a 41,000 year cycle. So we have three processes working in concert, which makes it very complicated. So the graph that I showed of the ice core temperature record, it's pretty erratic, and that's all these cycles coming into play.
Thank you very much to all four of you. I really appreciate it.